Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 3, longest substring without repeating characters. This is a medium difficulty problem, and in this problem we're told that we're given a string called S and we want to find the length of the longest substring without duplicate characters. And we're given a couple of examples. In the first example we have this string over here and the output is 3. And the reason the output is 3 is because the 3 substrings we can make without duplicate characters, the longest substring we can make is going to be of length 3. And there's 3 different results that could amount to the length of 3. That's ABC, BCA, and CAB. These are all correct answers. And because they all have the length of 3, we just want to return 3. And in this example, the answer is B, because the only substring, and the substring can be of length 1 as well, so the only substring that contains no duplicate characters, since they're all the same, is of length 1. So the answer is 1. So we're given some constraints as well, and we're told the string that we're given consists of English letters, digits, symbols, and spaces. So how can we solve this problem? Well, from an intuitive perspective, this is a sliding window problem. So let's actually, let me show an example. So let's say we have a string, let's say ABBA and ABBA. So we want to use a sliding window technique, don't we? So we want to say we're going through and we're scanning through each character in our string. And we come across the first A, and we want to have a hash set. We want to have a hash set somewhere in our program that stores the characters that we've already come across. So we haven't come across B, we haven't come across B. Oh, look at that, we've come across B again somewhere in our hash set. Let's just say, it's a little construct over here. So we've come across B. Well, what do we do now? Well, we need to now shrink our sliding window such that we basically no longer have any duplicates. So we shrink from A, and then we check again in our substring. Do we have a duplicate? Yes, we do. B still exists, so we want to shrink again. Until now, we only have B, and then we can move on to our next character. And so in this example, the longest substring, the length of the longest substring is going to be of length 2, BA or AB. So let's actually get coding up, now that we know the intuition behind solving this problem. So the first thing we want to do is create a hash set. We'll just set that to Python set. We want to have our left pointer, which is going to be equal to 0. And then we want to have a max length, which initially is also going to be equal to 0. And we want to iterate. We want to have our right pointer, which is going to be basically iterating through our string. So we want to say for R in range of length of S. Well, the first thing we can do is say, what if we're at the condition where we haven't seen this character before? Well, then we're just going to add to our hash set. We're going to add to our hash set SR, so character at the right pointer, and we want to then calculate the max length. So the max length is going to be equal to the max length. It's going to be equal to the max of the max length. So if the max length is already larger, then we just want to stick to that. Otherwise, it's going to be the window size plus 1. But what about the case where we've come across a character already? We already have a character in our hash set. Well, then we can say if this character is already in our hash set, we want to increment our left pointer, and we want to remove. So we want to remove from our hash set dot remove SL. And now, once our while loop, our for loop, and our while loop both finish, we should finally have our max length stored in our max L variable. So we can just do return max L like this. And now let's submit our code. And we pass all test cases for this problem. So once you understand the sliding window approach that we need to implement for this problem, it becomes a lot easier to understand and code up. The trick in this problem really is understanding that we do need to use a sliding window technique. So in terms of time complexity, guys, we're looking at a big O of n time complexity for time, and for space, we're looking at a big O of n for the space complexity as well. And that's because at the worst case scenario, each character is going to be unique, could span the entire alphabet, so it's going to be a big O of n for both time and space. And with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.